Let's bring in Tanya Harrison. She's the Director of Science Strategy at Planet Labs. She joins us from Washington, D.C. Really good to talk to you. Now, I was surprised to read that Venus actually has a number of characteristics similar to Earth. Can you tell us more about what those are?
So Venus is almost the same size as Earth, and in that regard, it's often referred to as Earth's twin in the solar system. But other than that, it's a pretty different place. The surface is under 90 times more air pressure than it is on Earth. The surface temperatures are about 500 degrees Celsius, so lead would melt on the surface. So it's not a very hospitable place compared to Earth, that's for sure.
So my understanding of the mission is they are hoping to better understand Earth by looking at Venus more closely. Why is that then?
Well, we're pretty sure that Mars used to be a lot more Earth-like in its ancient past, and we think that maybe Venus was a lot more Earth-like in its past as well. And so by trying to understand what Venus is like today and how it's changed over time, it might give us an idea of if it was more Earth-like in the past, and if so, what happened to turn it into what we see today? And is that any kind of clue as to what the future of the Earth might be like?
OK, so they're two separate missions, each gathering different kinds of data. Can you talk us through the purpose of each one?
So there's one called DAVINCI Plus, and these are all a little bit of an alphabet soup of acronyms. So DAVINCI Plus is the Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging. And this is an orbiter that will look at the clouds from above, paired with a probe that will actually go through the atmosphere of Venus to learn more about the composition of it. And then it will take some photographs as it's landing, because Venus has a really thick atmosphere that prevents us from actually imaging the surface with a traditional camera like we can do at the moon or Mars, for example. So this will give us some of the first good, clear pictures underneath the cloud deck of what the surface actually looks like. Then we have the second mission called VERITAS, which is the Venus Emissivity Radioscience INSAR Topography and Spectroscopy mission. And this one is an orbiter that has, among other things, a radar instrument on board. And radar lets us peer through those clouds of Venus to actually see what the topography of the surface looks like. And we've done that before with a Venus mission back in the early 1990s called Magellan, but our technology has come a long way since then. And specifically, the radar that we're going to use on VERITAS is really good at looking for changes. And so we can try to see things like, are the volcanoes on Venus still active? Is the surface still deforming? Because we don't actually know the answers to those questions for sure right now.
As you say, technology has come a long way. But despite that, how challenging a mission is this? Because as you say, it's a very inhospitable planet.
Well, for VERITAS, it's just staying in orbit, so it's not too bad for the spacecraft, but designing the probe for the DAVINCI mission will probably be the trickier part. You need to have something that can survive the sulfuric acid, the high temperatures, potentially wind that you might encounter on the way through the atmosphere. But we've never really done anything like that before on Venus, so it's going to be really interesting to see how that develops and how they test it here on Earth before they actually launch the mission.
And missions like this cost a lot to carry out. I believe this one is going to cost around $1 billion. For those who say that money could be better spent, say, here on Earth, what would you say as a scientist? Why is this critical?
Well, I like to remind people that that $1 billion isn't being sent to Venus. That $1 billion is being invested here on Earth. It's providing jobs for scientists, engineers, administrative staff that work at places like NASA and all of the universities and labs that are involved in these missions. So it provides a lot of jobs, and it provides a lot of inspiration to get people interested in working in science, technology, engineering, and mathematics. And so that's a really valuable thing that NASA is able to provide worldwide to give that kind of inspiration. And I think that that's a really great investment all around.
Really good to talk to you. Tanya Harrison, Director of Science Strategy at Planet Labs.